Now, to do part B, in part B, it tells me that the same car has a frictional force of 180 newtons acting on it. And of course, I would have had to put power from the engine, not only to moving me down the street, that 746 watts that we found in part A is still happening, but I also have to overcome that friction. That took power. So to find the total power the car needed, I need to find that power as well. But in this case, they've given me a force. So they've given me a force, which makes me think instead of energy, I'm going to use work. Because if I use the work equation, then using the work equation, I can find force times distance. Now, there's something very specific they say in here as well that it's important is it moves at a constant speed. Why do I need that? Well, I don't know the distance that it moves, right? I know it moves for 1 minute and I know its speed because I have those from part A. You'll notice up here in part A, I know that it's moving at 8.3 meters per second for 1 minute. So this will let me find the distance because at a constant speed, I know V equals D over T. So you kind of have to use all of our skills in this one. We have to use all of our skills from previous units. So I know it's velocity because they gave it to me in part A. That hasn't changed. It's the same car. I want to know how far does it go. So I can use my work equation. I need the distance. And I know it goes for 60 seconds because 8.3 meters per second, I need my time in seconds still. So 8.3 times 60 will give me my distance. So it moves in that time, and it is a car, so it moves a little distance. It goes 498 meters. Now remember, the reason we did this was so we could find the work done. And that is the tricky thing about this. It's not hard math, the power equation, but you do need to know all your other equations and you have to be able to think creatively, what am I doing? So this is going to be the force of friction. So this is going to tell me the work done to overcome friction, which is the thing I need to do for my power. So I know my force of friction. They gave that to me in the question. I now know how much distance we went for. So I can then find the work done to overcome friction. So multiply by my 180. And I now know to overcome friction, I needed 89,640. That'll be joules because work is in the same units as energy. And then we're going to do our power part, right? So I'm going to find how much power because it asks for the power. So power can be work over the time. So I know that I did 89,640 joules of work to overcome that friction in 60 seconds. Now, I know it's very tempting to make that a negative value, but remember, we put this work in. This was work that is not negative. It's positive because the engine had to do it, right? The engine is what's going to be doing that work. So that's why I'm keeping it in the positive range. So I needed 1494 watts to overcome it. Now you'll notice I didn't round that number and I'm going to find the total. So to find the total, I'm going to take my 746 that I had originally, right? My 746 from part A, and I'm going to add it to my 1494 I just found and get my total. And that's the thing I'm going to round, right? I don't want to round too early because then it messes with my numbers because it ends up changing things if I round and round and round. So this is what I'm going to report in my therefore sentence. So 2.2 times 10 to the 3 watts. And then, of course, I'll write a therefore sentence that deals with part A and part B together and uses those values.